Hello, I'm Logic Bunny, and come with me down the rabbit hole of knowledge. Imagine holding the entire observable universe in your hand. Every star, every galaxy, all the swirling nebulae compressed into something you could cradle. Feels kind of strange, right? To think that all that immensity, that breathtaking scale, is somehow connected to you, to us, here on this tiny blue planet. We're surrounded by mystery, cosmic questions that have baffled scientists and philosophers for centuries. What is dark matter? What is dark energy? Why haven't we found any other intelligent life in the universe, even though it should statistically exist? This is the Fermi Paradox. Where did life come from in the first place? And what is the ultimate destiny of the universe? Is it doomed to expand forever, or will it eventually collapse in on itself? Now, you might be thinking, okay, that's all pretty cool, but why should I care? Maybe you're busy with school, or friends, or figuring out what you're going to do this weekend. These cosmic questions seem so far removed from our everyday lives, but the truth is, pondering these mysteries isn't just for scientists in lab coats. It's for anyone who's ever looked up at the night sky and felt a sense of wonder thinking about these big questions. Even without having all the answers, can actually change the way you see the world. It pushes you to think critically, to question assumptions, and to open your mind to possibilities you never even imagined. It helps you to understand your place in the grand scheme of things. It reminds you that you're part of something much, much bigger than yourself. And that's a pretty amazing feeling. Ever feel like you're missing something? Like there's a whole other world happening, just out of sight? Well, the universe might feel the same way, because what we can actually see, all the stars, planets, and galaxies, only makes up about 5% of everything that's out there. That's right, just 5%. The rest, it's a mystery wrapped in an enigma, sprinkled with a little bit of scientific hedge. We call it dark matter and dark energy. Now, you might think dark matter is just some missing stuff, like socks that disappear in the laundry. But it's much stranger than that. It's an entirely different kind of matter, something we can't see or interact with using light. So how do we know it's there? Imagine a galaxy spinning around and around. Based on the amount of visible matter, it should fly apart, but it doesn't. Something is holding it together, providing extra gravity. That something is dark matter. It's like an invisible glue, keeping galaxies from falling apart. And then there's dark energy. If dark matter is the glue, dark energy is the cosmic gas pedal. For a long time, scientists thought the universe was expanding, but that the expansion was slowing down. But then, they made a shocking discovery. The universe isn't just expanding, it's accelerating. Imagine blowing up a balloon, and instead of slowing down as it gets bigger, it starts inflating faster and faster. That's what dark energy is doing to the universe. It's a mysterious force that's pushing everything apart. So, how do scientists study something they can't see? They use a technique called gravitational lensing. Imagine a really massive object, like a giant galaxy cluster, sitting in space. Its gravity is so strong that it can actually bend the light from objects behind it. It's like looking through a giant magnifying glass. By studying how the light is bent and distorted, scientists can map out the distribution of dark matter. It's like being a cosmic detective, using clues to solve a mystery. Think of it this way. Dark matter is like the ocean current guiding ships on the surface. You can't see the current, but you can see how it affects the ships. Galaxies are like those ships, and dark matter is the invisible current shaping their movements. Dark energy, then, is the wind in the sails, pushing everything along at an ever-increasing speed. It's a strange and wonderful universe we live in, isn't it? Full of things we can't see, but that have a profound impact on everything we do. See what other hidden forces might be shaping our reality. Ever look up at the stars and feel incredibly small? It's easy to feel like just a tiny speck in this enormous universe. And that feeling can lead to some pretty big questions. One of the biggest is this: if the universe is so incredibly old and vast, with billions of galaxies and potentially trillions of planets, why haven't we found any other intelligent life? This is the Fermi Paradox, and it's a real head-scratcher. Now, there are lots of possible explanations. One popular idea is that they're hiding from us, that there's some kind of galactic club and we haven't been invited yet. Maybe they're watching us, waiting for us to reach a certain level of development before they make contact. But while that's a fun idea to think about, there might be simpler and perhaps more unsettling explanations. One of the most popular is the Great Filter Theory. Imagine a series of hurdles that every civilization has to overcome to reach interstellar travel. Things like developing complex life, evolving intelligence, mastering technology, and avoiding self-destruction. The Great Filter suggests that there's something that prevents most, if not all, civilizations from making it through all those hurdles. Maybe intelligence is rarer than we think. Maybe the conditions for life to arise are incredibly specific. Or maybe, and this is the scary part, maybe intelligent civilizations tend to destroy themselves before they reach the stars. The lack of contact could be a warning sign about our own future. Are we on a path to self-destruction? Are we about to encounter our own great filter? So, how do scientists even try to figure out the odds of finding extraterrestrial life? They use something called the Drake equation. It's not really an equation that gives you a definitive answer, but more of a framework for thinking about all the different factors that go into estimating the number of intelligent civilizations in our galaxy. It takes into account things like the rate of star formation, the number of planets per star, the fraction of planets that could potentially support life, the fraction of those planets that actually develop life, the fraction of those that develop intelligent life, the fraction of those that develop technology, and the length of time that those civilizations are detectable. As the science fiction writer Arthur C. Clarke famously said, two possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying. Think about that for a moment. If we're alone, it means that we're responsible for the future of intelligence in the universe. That's a huge burden. But if we're not alone, it means that there are other civilizations out there, and we have no idea what their intentions might be. Are they friendly? Are they hostile? Or are they simply indifferent to our existence? What does the silence of the cosmos really mean? Let's explore this together. Ever stared at a blank page, a lump of clay, or just nothing, and wondered how something could come from it? It's a question that's plagued philosophers and scientists for ages. But when we turn that question to the universe, it becomes even more mind-boggling. How did non-living matter, simple chemicals, somehow become living cells? How did nothing turn into everything? Now, it's easy to imagine that life just spontaneously appeared, fully formed, like magic. But the reality is probably a much more gradual process, a sort of chemical evolution. Think of it as a series of tiny steps, each one building on the last, slowly leading to the complex structures we see in living things today. One of the most famous experiments that explored this idea was the Miller-Urey experiment. Back in the 1950s, these scientists created a simulation of early Earth conditions in a lab. They mixed together water, methane, ammonia, and hydrogen, and then zapped it with electricity to mimic lightning. And guess what? They found that amino acids, the building blocks of proteins, started to form. It was a huge breakthrough, showing that the basic ingredients for life could arise from non-living matter for a long time. Scientists thought that DNA was the first genetic material, but now many believe that RNA might have come first. RNA is similar to DNA, but it's simpler and it can do more things. It can store information just like DNA, but it can also act as an enzyme, catalyzing chemical reactions. Imagine RNA molecules folding into different shapes, each shape performing a different task. It's like a tiny self-replicating machine. So, where else might we find the building blocks of life? Scientists are looking beyond Earth to other planets and moons in our solar system. This field is called astrobiology. Places like Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, have oceans of liquid water beneath their icy surfaces. And where there's water, there's a possibility of life. Scientists are sending probes to these places to look for organic molecules, the same kinds of molecules that were found in the Miller-Urey experiment. Think of life as a self-assembling Lego set. You start with simple bricks, the basic chemical building blocks. And then, over time, those bricks start to connect and form more complex structures. Eventually, you end up with a fully functioning Lego model, a living cell. It's a long and complicated process, but it all starts with those simple beginnings. That's a great question. What other seemingly impossible things might be possible with the right combination of ingredients and time? Ever feel like everything is temporary? Like nothing lasts forever? Well, when you start thinking about the universe, that feeling gets amplified to an epic scale because the universe itself has a beginning, a middle, and, presumably, an end. The question is, what will that end look like? What is the ultimate fate of the universe? Now, I know, talking about the end of the universe can be a bit of a downer, but don't worry. We're not talking about something that's going to happen next Tuesday. The universe has billions of years left, so you can relax and enjoy the ride. But it's still fascinating to think about the possibilities. You might have heard of the Big Bang, the event that started the universe as we know it. And you might think that the end is just the reverse of the Big Bang, a big crunch where everything collapses back into a single point. And that is one possibility. But there are others. One is the Big Rip. Remember how we talked about dark energy? The mysterious force that's causing the universe to expand at an accelerating rate. Well, if that acceleration continues to increase, eventually it could become so strong that it overcomes all other forces, even gravity. And if that happens, everything will be torn apart. Galaxies, stars, planets, even atoms themselves. It's a pretty dramatic scenario. Another possibility is heat death. This is a more gradual and less violent end. As the universe expands, the energy within it becomes more and more spread out. Eventually, there won't be enough energy left to do anything. Stars will burn out, galaxies will fade, and everything will cool down to absolute zero. It's a slow, cold, and lonely end. So how do scientists try to figure out which of these scenarios is most likely? They study the cosmic microwave background radiation. This is the afterglow of the Big Bang, the oldest light in the universe. By studying the CMB, scientists can learn about the universe's age, composition, and expansion rate. It's like looking at a baby picture of the universe to try to predict its future. Think of the universe like a rubber band. You can stretch it and stretch it and stretch it. Will it eventually snap, like in the Big Rip scenario? Will it contract back to its original size, like in the Big Crunch scenario? Or will it gradually lose its elasticity and just become limp and lifeless, like in the heat death scenario? The answer, my friends, is still out there, waiting to be discovered. The possibilities are endless. What does it mean to live in a universe with a finite lifespan? Does it make our existence more precious or more meaningless? Ever feel like you're just a tiny speck in the grand scheme of things? Like your life doesn't really matter? It's easy to feel insignificant when you think about the vastness of the universe. But the funny thing is, understanding the universe can actually make you feel more connected and important. Now, you might think that cosmic knowledge is useless in everyday life, that knowing about dark matter or the fate of the universe doesn't really help you with your homework or your relationships or your future career. But the truth is, it does. Studying the universe cultivates critical thinking, problem-solving skills, and a sense of wonder. These are all valuable assets that can help you navigate any challenge, big or small. Don't think about it. When you're faced with a difficult problem, whether it's a math equation or a social dilemma, you need to be able to analyze the situation, identify the key factors, and come up with creative solutions. These are the same skills that scientists use to unravel the mysteries of the universe. The more you exercise your mind, the better you become at solving problems, no matter what they are. And then there's the sense of wonder. When you look up at the night sky and contemplate the immensity of the cosmos, it can fill you with a sense of awe and inspiration. It reminds you that there's more to life than just the everyday grind. It encourages you to dream big, to explore new possibilities, and to never stop learning. And here's something else to think about. We are all made of star stuff. The elements that make up our bodies, the carbon, oxygen, nitrogen, All of those were forged in the hearts of dying stars billions of years ago. When those stars exploded, they scattered those elements throughout the universe, and eventually they became part of us. So, in a very real sense, we are all connected to the stars. We are all part of the same cosmic family. Let's try a little exercise. I want you to imagine that you're looking back at Earth from space. You see our planet as a tiny blue dot, a fragile oasis in the vastness of the cosmos. This is the pale blue dot, as Carl Sagan called it. When you see Earth from that perspective, it changes everything. It makes you realize how precious and fragile our planet is, and how important it is for us to take care of it. It makes you realize that we're all in this together, that we share a common home, and that we have a shared responsibility for its future. As Carl Sagan so beautifully put it, for small creatures such as we, the vastness is bearable only through love. Love for our planet, love for each other, and love for the universe that has brought us all into being. That's a great question. What small act of love can you offer to the universe today? So we've journeyed through some of the biggest mysteries in the universe. Dark matter, dark energy, the Fermi Paradox, the origin of life, and the ultimate fate of everything. These are questions that have puzzled scientists and philosophers for centuries, and we still don't have all the answers. But that's okay. The point isn't to have all the answers, but to keep asking the questions. I hope this exploration has sparked your curiosity and inspired you to learn more. There are so many amazing resources out there. Books, documentaries, websites, all waiting to be discovered. Dive in, explore, and let your mind wander. And remember, it's important to think critically and to question assumptions. Don't just accept what you're told. Do your own research, form your own opinions, and be open to changing your mind as you learn more. That's what science is all about. The universe is a vast and wondrous place, full of endless possibilities. And the more we learn about it, the more we realize how much we still don't know. But that's the beauty of it. There's always something new to discover, something new to explore. So keep exploring, keep questioning, and never lose your sense of wonder. Your cosmic journey starts now. What will you discover?